Alright, so these congruent triangles, angle, angle, side, side, angle, side, 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 or angle, side, angle, or HL, known as angle, side, side. Angle, side, side only works if it's a right angle. So we use HL, meaning hypotenuse leg. These are the ways we can prove that two triangles are congruent. And it's all about the relationship of the angles and the sides. If certain sides are, remember last chapter we had that if the angles are congruent, right? And the sides were congruent, 1, 2, 3, 1, 2, 1, with another one, that the triangles were congruent. So this one had a 1, 2, 3, 1, 2, 3. This one was a 1 and a 1, and this one was a 1, 2, and a 1, 2. And so since these had all congruent relationships between angles and sides, angles and sides, and angles and sides, right? That these two were congruent. Well, now we can actually step it up and pull back. We don't have to have every single angle and every single side to be a congruent relationship for the triangles to be congruent. There's actually these 5 situations that will make the triangles congruent. So if I have angle, angle, side, so that means if I have angle, right? Angle, right? And then side. And as long as those two angles on the other triangle are congruent in that order, like angle, angle, side, you notice how they don't have to, they just have to be some kind of order. It could be angle, angle, side, angle, angle, side, or it could be, in this case, angle, angle, side, but as long as it's on the two triangles, that they go in that order. Angle and an angle and a side, and an angle and an angle and a side. Then we'll know that those two are congruent. If they go in the order of side, angle, side. So any side. You want the bottom, the top? Which side do you want? Bottom, left, or right? Which side do you want to start with? Bottom. So, and you said left. So I'm going to go bottom and left, right? Which means I have to have the angle in between, right? For it to be sassy, for it to be SAS, right? So this angle in between them, side, angle, side, has to be congruent with something over here, okay? And that means it doesn't even matter what they look like. You notice how they look? It doesn't matter what they look like. What matters is that you have the side and the angle, and the side can be reflected upon this piece. Now the shape might look different, right? But the math is what matters. It's all about the math. Okay? It's not about the shape, it's about the math. If this angle and this angle and then this side and this, or sorry, this side and this side and this angle and this angle and this side and this side are congruent, SAS, then the two triangles are congruent. In the same aspect, with the side, 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 if I have a 1 and a 2 and a 3, and they're congruent with a 1 and a 2 and a 3, right? Then that means that these two triangles are congruent. And if the triangles are congruent, that means their angles are congruent too, right? It's not just their sides. Both their sides and their angles, they're all congruent. Okay, so a lot of math is going to come out of this. Alright? So then we've got angle, side, angle. Okay? Which means if I've got angle, side, and an angle, right? Then over here somewhere I need an angle, a side, and an angle. And if I have that, then that means that these two triangles are congruent. Okay? And lastly, we have the hypotenuse leg. And that's an angle side side, but it only works with the right triangle. And let me show you. So basically, I have a hypotenuse leg, which means I could have, that means the hypotenuse is always the one that's opposite of the right angle, right? So this has to be congruent to this. Okay? And if it is, then if the other leg is congruent to the other leg, right? They have two congruent